Hello and welcome back to this series of learning that we are calling Modern Operating System. If you have been with us, last time we looked at the table of contents, and we looked at section 4, which is the file system, and we looked at section 5, which is the input and output. Then we looked at section 6, which is deadlocks, section 7, which is virtualization on the cloud, and then we looked at section 8, which is multiple processor systems. Now we're going to look at what is contained in the other sections of the table of contents, and we'll go to section 9, which is security. So we look at the security environment. So we look at threats, we look at attackers here, we look at operating system security. Here we're asking the question, can we build server systems, can we build secure systems? And also we are looking at trusted computing base. Then we are looking at controlling access to resources, protection domains. We are looking at access control lists. We are looking at capabilities. Then we are looking at formal models of secure systems. We are looking at multi-level security, and we are looking at convert channels. Then we are looking at basics of cryptography. So we are looking at secret key cryptography. We are looking at public key cryptography, one-way function, digital signatures, and trusted platform modules. These are security features that we are experiencing a lot today in our system. For example, if you use any API, you will know about public key cryptography. Here also we look at authentication. We are looking at authentication using physical objects. Okay, we are experiencing a lot of this today. Also we are looking at authentication using biometrics. So biometrics again is coming up. You're using a lot of face recognition and thumbprint or finger recognition. We're seeing biometrics here. Then we are looking at exploiting software. We are looking at buffer overflow attacks. We look at format string attacks. We should look at dangling pointers. We look at null pointers, difference attackers. We look at integer overflow attacks. We look at command injection attacks. We look at time of check to time of use attack, time-based attacks. Then we shall look at inside attacks. We look at logic bombs. We look at backdoors. We look at logging spoofing. We look at also malware. We look at Trojan horses. We look at viruses. We look at worms. We look at spyware, and we look at rootkits. Then we look at defenses. We look at firewalls. We look at antivirus and antivirus techniques. We look at code signing. We look at jailing. We look at model-based intrusion detection. We look at encapsulating mobile code, and then we look at Java security. Then we'll look at the research on security and the summary. Then we'll do case study 1, which is Unix, Linux, and Android. So we look at the history of Unix and Linux. We look at Unix. We look at PDP-11 Unix. We look at portable Unix. We look at Berkeley Unix. We look at standard Unix. We look at Minix, which was created by the author of this book. And then we look at Linux. Then we look at overview of Linux. Then we look at Linux goals. We look at interface to Linux. We look at the shell. We look at Linux utility programs, and then we look at the kernel structure of Linux. Then we look at processes in Linux. We shall look at fundamental concept. We look at process management system calls in Linux. We look at implementation of processes and threads in Linux. We look at scheduling in Linux, and we look at booting in Linux. This is an actual operating system, so the case study will help us understand what we have learned about the principles of operating system, and now see it working in an actual operating system. We'll also look at memory management in Linux. We look at fundamental concepts. We look at memory management system calls in Linux. We look at implementation of memory management in Linux. We look at paging in Linux. We'll also look at input and output in Linux. We look at fundamental concepts. We look at networking. We look at input and output system calls in Linux. We look at implementation of input and output in Linux. And then we look at modules in Linux. Then we look at the Linux file system. We look at the fundamental concepts. We look at file system calls in Linux. We look at implementation of the Linux file system. And then we look at NFS, the network file system. This is a file system used to partition hard drives and stuff. So if you have done some partitioning, you must have made the NFS somewhere. We look at security in Linux. We look at fundamental concepts. We look at security system calls in Linux. We look at implementation of security in Linux. Then, since Android is a Linux-based system, we'll go straight into Android and look at Android and Google. We'll look at the history of Android. We look at design goals. We'll look at Android architecture. We look at Linux extensions. We look at Dalvik. We look at Binder IPC. We look at Android application. We look at intent. We look at application sandboxes, and then we look at security, and then we look at process models. Then we'll do a summary of that. Then we'll go into the second case study, which is Windows 8. I know this is a very old Windows, but just understanding the concept, because the Windows 8 and Windows 10 are kind of related. So you can be able to even learn more about Windows 11. There's an actual edition, I think is edition 7, edition 5, or this another edition which now talks about Windows 11. So let's first understand it, and then we'll go into that. So here we look at the history of Windows through Windows 8.1. We look at 1980s MS-DOS. We look at 1990s MS-DOS based Windows. Then we look at 2000s NT based Windows. Then we look at Windows Vista. It's in page 862, and then we look at modern Windows. Then we look at programming Windows. Then we look at the native and application programming interface. We look at Windows 32 application programming interface, and then we look at Windows registry. Then we look at the system structure, operating system structure. We look at booting Windows. We look at implementation of the object manager. Then we look at subsystems, the DLL and the user model services. Then we look at processes and threads in Windows. We look at fundamental concepts. We look at job processes, threads, and fiber management API calls. We look at implementation of processes and threads. Then we look at memory management. We look at fundamental concepts here. We look at memory management system calls. We look at implementation of memory management. Then we look at caching in Windows. Then we look at input and output in Windows. Then we look at fundamental concepts. We look at input and output API calls. Then we look at implementation of input and output in Windows. Then we look at Windows NT file system. Then we look at fundamental concepts. We look at implementation of the NT file system. Then we look at Windows Power Management. We look at security in Windows 8. We look at fundamental concepts. We look at security API calls. We look at implementation of security and the security mitigations. Then we'll do a summary, and after that we'll go into operating system design. This is our last chapter. Here we look at the nature of the design problem. We look at goals. We look why is it hard to design an operating system. Then we look at interface designs. We look at guiding principles. We'll look at paradigms. We look at system call interface. We look at implementation system structure. We look at mechanism versus policy. We look at orthogonality. We look at naming. We look at binding time. We look at static versus dynamic structures. We look at top-down versus bottom-up implementation. We look at synchronous versus asynchronous communication. We look at useful techniques. Then we look at performance. Why are operating systems slow? We look at what should be optimized. We look at space-time trade-offs. We look at caching. We look at hints. We look at exploiting locality. We look at optimizing the common case. We look at project management. We look at the mythical month. We look at team structure. We look at role of experience, and we look at no silver bullet. Then we look at trends in operating system design. We look at virtualization and the cloud. We look at many core chips. We look at large address space operating systems. We look at seamless data access. We look at battery powered computers, and then we look at embedded systems. Then we do a summary of that. Then after that, you have a reading list and a bibliography, suggestions for further reading. There's an introduction there. There's books about processes and thread recommended, books about memory management recommended, books about file system, books about input and output, books about deadlocks, books about virtualization and the cloud, books about multiple processor system, books about security, more case studies, the Unix, Linux, and Android, more case studies about the Windows 8, and more case studies about operating system design, alphabetical bibliography. So yeah, and then there's the index there. Yeah, you know the rest. So Now we are done with the table of content, and in the next section we are going to be looking at the preface. So we're going to read the preface just to understand what is contained in this book, because it's the fourth edition, not the first edition. So definitely there are things that have changed here. So in the next episode we shall going to be reading about that. So looking forward to you joining me in that one. Thank you for joining me in this one, and let's keep reading.